The repartee that we're going to talk about beyond membranes. So I want to thank everyone for coming to the event, and especially thanks to our 4 panelists who have agreed to share their experiences on and view on how to improve the performance of membrane systems. So some of you may wonder, what is a repartee? First time John mentioned it to me, I also wondered. I went to the all-knowing, i.e. I went to Google, and asked what is a repartee. And if you did the same thing I did, you'll find out that it is a conversation or speech characterized by quick and witty comments and replies. All right, this is Friday afternoon, evening for you, Sivan. So I don't know how witty we will be, but I'm hoping that we'll have an interesting and engaging conversation with the 4 companies that are with us today. So with that, we chose the title for today's repartee, Beyond the Membrane, to highlight alternate approaches for improving the performance of membrane systems. The kind of approaches that do not involve changing the membrane material or surface. As we said in the invite, the vast majority of the membranes used today are polymeric, and they are based on work that was done in the early 60s. A number of different membrane chemistries and manufacturing processes were developed, and by the mid-70s, the membrane started getting significant commercial traction. And since then, most of the work has been focused on improving throughput, separation capability, and cost. And we have seen some really dramatic changes. So I know I'm going to date myself with this, but when I first started working with RO membranes, the price for an 8-inch spiral RO was well north of $1,600. Today, when purchased in quantity, price is well below $400 for a membrane module with much better performance and longer life. So in my mind, I'm feeling in a way that we're reaching the maximum of what we can squeeze out of membranes by modifying the chemistry and improving the manufacturing process. So personally, I believe the next big step in improving performance will be in optimizing hydraulics and operations. And that is where the companies are here with us today come in. They all have developed new technologies and approaches for improving membrane system performance, and none of it involves changing the membrane chemistry. So our panelists today come from different backgrounds, and each have had a different path to the exciting world of membranes. We have Melanie, she's the CEO of Swirltex, and they have developed what they refer to as buoyancy-based membrane filtration. Craig, CEO of Aqua Membranes, is commercializing a printed spacer. You print the spacer right on the membrane. Devesh is the founder and CEO of Epani Energy, and they're using technologies like machine learning to optimize membrane operations. And Sivan is the CEO of Noria Water Technologies, and they are able to optimize the performance of membrane-based treatment with real-time surface monitoring and machine learning as well. So 4 different approaches for improving performance of membrane systems, and I'm really looking forward to hear what each of them have to say. So about the format for today. So this is a very informal event. There is so much impressive tech that has potential of having significant impact on how we in a responsible way manage water and how we can be good stewards of the resource. So we want to highlight the innovations. So we'll begin with each company going ahead and introducing themselves, discussing the problem they're solving and the solution they're providing, and talking a little bit about the customers in the markets, as well as their successes. After that, by the way, I may throw in a question or two in there that has nothing to do with membranes as well, so just be prepared for that. And after that, the floor is open for questions. You can use the chat functionality to send questions, and I will incorporate into the discussion. In the chat, make sure that you indicate who you want the question to go to. And also, based on what we have seen at previous events, we may not get to all the questions, but rest assured, we will document the questions and we'll get them to the right person. Or you can also send us an email and we'll go ahead and get the question to the right person. So with that, let's get started. Melanie, do you want to get started?
Sure. Can you hear me okay?
Yes.
Can you? Okay, great. Hi, everybody. Thanks so much, Anders. I'm Melanie McClare. We're with Swirltex. Swirltex is a technology company based in Calgary, Alberta, Canada. And we have developed a new process called buoyancy-based membrane filtration. And this process enables us to manipulate membrane performance by not, as Anders mentioned, not manipulating the membrane itself, but more working on the fluid mechanics of the system. And so what we do is a two-step process. We manipulate the buoyancy of the contaminant stream upstream of the membrane using a gas, and then we swirl the fluid through a tubular membrane. And that creates a density differential, creates a centrifugal force that enables the contaminants to stay away from the membrane surface and us to create a shear velocity, tangential velocity against the membrane, which basically all that means is an increase in flux and a decrease in fouling, which is the main problem of membranes today. And the main problems that we're solving are for customers that have high strength wastewaters, heavy solids, oily wastewaters. And so our customers are industrial customers like oil and gas, power industry, food and beverage wastewater, stormwater type applications where you wouldn't normally deploy a membrane. So we're looking to use membranes where they've never been used before. And our most recent key successes are in getting our product to market. So just in the last 6 months, we've been able to get our prototypes and our pilots out into the marketplace in 3 different market verticals, which we're really excited about. So now it's about developing that commercial scale product and getting to market faster. So thanks so much. That's the intro to Swirltex.
Thanks, Melanie. Appreciate that. So Craig, do you want to go next?
Sure. Thanks, Anders. Craig Beckman, I'm the current CEO of Aqua Membranes. As Anders said, we're working on the spacer material in spiral wound membrane elements. I've been in membranes for about 28 years now. And the problem we're solving is one that's been around from the beginning. A spiral wound membrane was rolled up on a center tube 50 years ago with a spacer material to create the gap between the layers and also create turbulence. And it's pretty much been unchanged. There have been small tweaks in the angles, the strands meet each other and the thickness, but we've really reached a limit of how much we can improve that with the existing geometry, with the extruded mesh that's used. So about 8-9 years ago, we filed some IP on the notion of taking that material out of the spiral package and instead actually depositing material directly on the membrane surface. So we can print dots, lines, squares, chevrons, really any shape we want. And it allows us to do a lot of things with membranes that are not possible today. One example of that is actually making the spacer material much thinner. So at a comparable pressure drop, we can actually put 30-40% more area into an existing membrane element. This lowers the cost of new builds because you need fewer skids, smaller building, et cetera. But where we're seeing some of the early interest are with customers that have an existing system. So a drought-prone city, for example, or a beverage plant that needs to do expansion to add another line, but they don't want to add more membrane skids. With a pump change and a membrane change, potentially they can increase their output by 30%. So that's a really big value proposition we're offering today and getting a lot of market pull. We also see future opportunities to actually change the dynamics of the flow inside the package. Today, your typical spiral wound element is going to have at least 5 times as much cross flow as permeation through the membrane. And that excessive cross flow in many applications wastes water. Even with a lot of the new technologies on the market today, pushing the recoveries of membrane systems, there's still a lot of membrane systems that dump 20, 30, 40% of the water. And in home systems, it's even worse. China's leading the market today to push that, but even there, best in class dumps 25% of the water down the drain. So we see an opportunity to develop some new custom spacers that would allow membranes to follow more slowly at higher recoveries and therefore waste less water. So the problem we're solving is wasted water, wasted energy associated with the spacer material, and are excited to bring the product to market.
Thanks, Craig. Good summary. I'm going to ask you a question here.
Sure.
Off the wall. What's the best piece of advice you've ever heard?
That's a good one. My first boss in the industry, his name was Lee Combe, and in 1993, I started selling membrane systems for him in Detroit. And he had like a list of 10 things that good salespeople should do. And at my heart, I'm a CEO, but I'm mostly a salesperson. And he said, never go to plan B until plan A fails. And I've actually found that lesson very interesting now being a CEO here and then my last job at Myox, that as leaders, very often, if we don't get the answer we're looking for quickly, we jump to something new where we just needed more time and that first thing would have panned out. So that was 28 years ago or so. He gave me that advice, and I just gave it to one of my salespeople the other day.
Nice. All right, Sivan, do you want to give an intro?
Yeah, absolutely. So my name is Sivan Cohen. I'm the CEO of Noria Water Technologies. And our flagship technology in particular that we're talking about today, addressing membrane-based water treatment, basically in an RO process, as Craig alluded to earlier, operators do everything they can to avoid ruining the membranes, including or particularly membrane fouling and mineral scaling, through a number of operational adjustments that they make regarding chemical dosing, cleanings, and so on. And our premise is that that's pretty hard to do, given that under actual operating conditions, operators can't actually see the membranes that they're trying to save. So they're more or less flying blind. So with that in mind, at Noria, we developed the RO Spotlight, which is a real-time spiral wound RO and NF membrane monitoring and operator decision support system. The RO Spotlight system that we've developed, it's both a hardware and a software system that enables plant operators to look directly at the membrane surface under operating conditions, detect the early onset and the progression of membrane fouling and scaling. Also, the machine learning portion that Anders mentioned is to identify the type of fouling and scaling material that's building up on the membrane surface, and then to really close that data loop and provide real-time recommendations to operators for improved plant performance. We've shown that we can cut up to 30% in annual RO plant operating costs through a combination of reduced chemical and energy use, optimized cleaning procedures, increased productivity, and a longer membrane lifespan. And I think one of the things that's important to point out is so often, this is more of a general comment, when we talk about reverse osmosis, people automatically jump to and think about seawater desalination. And so it's really, we're looking at any type of spiral wound RO or nanofiltration membrane across industry segments, and that could be extended in the future in terms of our development to other types of membranes, looking at UF and otherwise. So that's what we're working on. Some of our most recent successes or wins has been working with the Orange County Water District in Southern California, and also with the city of Santa Monica. So getting a lot of really great experience there.
All right. Thanks, Sivan. Yeah, I'll give you a question as well. If you could pick a new skill in an instant, what would it be?
Oh, that's easy for me. I would want to learn Arabic.
Oh.
Yeah, it's not related to my job on a day-to-day basis, but that's something that I'd be very interested in.
All right, Devesh, now that you're drinking, we can ask you a question.
Hey, can you hear me okay?
Yeah, we can.
Awesome. So my name is Devesh. I'm the CEO and founder of Pani Energy. It's a company that spun out of University of Victoria, University in British Columbia, where I, kind of romantically got in love with how can we improve the efficiencies of water and wastewater treatment assets. without necessarily doing a retrofit or without necessarily changing the design or anything to the plant. And with over 5-6 years of research, we found a lot of opportunities there from an academic standpoint, and that's when we spun out the company in 2017. And something I'm really happy I did afterwards, I went out and talked to a lot of plants, owners, and operators. We, over the last 2 years, have chatted with more than 150 owners and operators of actual plants across our target markets, which are India, Southeast Asia, and North America. And what we found out that the incumbent technology of data flow for operators is doing a really good job in terms of monitoring the existing sensors out there. But it's still a huge gap for operators to accurately diagnose actually what's the state of their plant. And even with influent conditions varying, it's up to their experience on what action they have to take. And to merge that gap is what Pani does. So Pani is basically an AI digital operator coach that looks at the entirety of the plant, learns from the ins and out of the plant from historical data, and then provides real-time suggestions to the operators, not just for one asset, but considering what's before, upstream, and downstream of the asset as well. And based on that, the operators take the action, and they can reduce operation costs for the entire plant around 15%. They can prevent downtimes, and by able to prevent and forecast some of the events in the future, they can meet their effluent targets, which is quite a critical issue for a lot of the effluent treatment plants. And one analogy I like to give, I was reading this book. It's called The Grid by Matt Watkinson. Highly recommend. And there, the author actually had an issue. He had a chronic knee pain for a long time, and he used to go to several doctors who were looking at the symptoms, but weren't really able to find a solution. So he took a drastic solution and did surgery. He did knee surgery on both knees. But even after that, he had still the same chronic pain. He went to a lot of physiotherapists, did hours of exercise, but his knees were still quite in pain, and he was close to making a decision of living a life of chronic knee pain, which you can only imagine would be quite difficult. But at the end, he came across a sports rehabilitation professional, and she, instead of just looking at the knee, she looked at his whole body. And she found that there was an imbalance in his muscles from shoulder to toe that created a misalignment in his hip bone that put too much pressure on the knees. And so he worked on his muscle for 2 months, and he was able to jog again. And what she did differently, she didn't just look at the symptoms for that knee, she looked at the root cause and actually tried to find the solution to the problem. And I think that's missing in the plants today. So that's what we bring to the plants. We do all the heavy lifting for them through model of the plant, running through historical data, and just tell the operator a simple suggestion which they can implement. In terms of our target markets, we focus on medium to large water and wastewater treatment plants, going from membrane assets, chemical reaction, as well as biological treatment. And I would say a key success, there's so many success. When you're running a company, you want to look at the success as much as you want to learn from failures. I think similar to Melanie, a big success for us is entering the commercial journey of the company. We've been invested in building a strong product over the years, and early this year and end of last year, we started getting some more commercial projects. And I'm really happy to have really good early adopters who've been allowing us to shape the product quite well.
Good. Thanks, Devesh. Let me ask you a question unrelated then. So what is something you want to do in the next year that you haven't ever done before?
I don't know if this will be possible anymore with COVID, but I've been hoping to go climb up Mount Kilimanjaro with my friends. And let's fingers crossed that's something I can do that next year.
Wow, that would be something.
Yes.
Nice. All right. So let's get started with some questions here. So Melanie, let me ask you first. Where do you think your offering is going to make the biggest difference?
Well, we think that We think that membranes have had a hard reputation, a hard history in certain oily water applications, and therefore, new technologies have come to market like ceramics, etc. And where I think we'll make the biggest impact is being able to deploy polymeric membranes at a fraction of the cost of a ceramic in oily water applications. So customers that wouldn't normally be able to afford a membrane solution might be able to look at a membrane solution now because they can deploy polymerics and keep the oil off the surface of the membrane, which is novel and unique to what we're doing, and helping these customers achieve really highly consistent, membrane grade water with one unit operation rather than a few in line. So we're excited about that.
Okay. So Craig, a question came in for you.
Mm-hmm.
So did you consider printing certain materials that could contribute to act as a repellent to fouling materials?
Yeah, it is an interesting question, and something that is in one of our claims of the patents we filed. The idea of putting an anti-scalant or even certain types of metals into the spacer material to slow down the fouling. We've done a little bit of modeling on that, just computer modeling. At this point, we haven't built any elements like that. But to be honest, what we've found in the last probably 2 years as we've ramped up some of our pilot, both computer modeling as well as field pilots, the flow and the channel size is actually more influential, we think, on keeping down biofouling and scale formation. So we're focusing more on that of, can we change the flow paths, speed up, slow down, kind of some of the same research that's being done and commercialization of other products of this notion of letting, especially on the scale side, precipitates to start and then breaking up before they actually crystallize, or those types of mechanisms. We're putting more time and work into just the same resin, but in different patterns, changing the height of the spacer so it has to accelerate and slow down as it goes through the channel. And then also playing around with how could we actually use the shear force of the membrane. So if the membrane gap can actually get close enough together, can you get some turbulence and shear force right off the side of the membrane and not have to put it in, not have to make it with the spacer material. So a little bit, but not much, I guess, would be the summary to the answer.
Okay. To the audience, please feel free to send in questions. We will cover them here as we go along. Next question is for Sivan. So what was it that really got you started in doing what you're doing? So how did you hook on to the idea that became the foundation for your company?
Sure. So our company, Noria, we initially had started out doing a number of consulting products and consulting work, specifically with RO plants. My partners are experts in advanced water treatment and reverse osmosis and desalination and membranes. And really quickly found with the customers that we were serving that, like I said before, they were really just flying blind and either under or over conservatively operating their plants, specifically because of the inability to see the membrane surface. So we thought to ourselves, well, what if we could actually see the membrane surface under operating conditions, not take an autopsy and be disruptive to the plant and send it off to a lab and get that back a couple days or a few weeks later, depending on the resources at hand. And so we went about developing a system to do that. From my perspective, I mean, there's a lot of different metaphors for it, but it's like driving a car without being able to see under the hood, as an example. And so that's really what brought the technology about, and we were trying to solve a real problem that we saw in the market, and we've gotten a lot of enthusiastic response, particularly from operators.
Okay. Devesh, what is your elevator speech? You have a complicated offering. It's hard to explain. How do you get someone to truly latch on to what you're saying in the first 20 seconds?
Okay. Well, hey, customer. In simple terms, we provide a digital operator coach that learns the ins and out of your plant so that it can work with your operators and run thousands of simulations and suggest them the right control suggestions on chemical dosing, on pressures, flow rates, from the start to the end of the plant. That reduces the operation cost around 15%, prevents costly downtime, and can look ahead. So you can prevent events that could potentially allow you to miss your effluent targets. And all of this through a $0 cap, which is low risk monthly subscription. And the best part is that it requires no retrofit, no downtime, no disruption, and you won't even notice while I'm integrating it.
Okay, well, that's good. Okay, so
one thing I forgot to mention, sorry, Anders, I think it's a key point, is that the ROI or the impact they would receive is 2 to 10 times on the monthly subscription they're paying us.
That's good. Okay, so a common question for all four of you, we can go through all of you again, starting with Melanie. Where can you talk about where you're at in your commercialization cycle? How far along are you? And what does a customer need to do to have a chance to test your technology?
Yeah, so where are we at? We have developed multiple pilot systems that have been deployed in the field in different market verticals for paid pilots. The way that we do our sales at SwirlTex is a three-step process. We give customers that have a pain point that might be a good fit for SwirlTex visibility to what a full-scale system would cost right at the beginning of the conversation. So we can determine right here and there, what they're willing and what they're able to invest in solving their problem. And then we back up and say, okay, here's how we get to market with you. We do a bench scale test in our lab. And then we move, if that works well and we provide a report and a feasibility, we move next step, which is a pilot. And we're currently in the field now with 3 different, like I said, market verticals at that pilot phase. And with these customers, they've already invested in bench. They've already gotten excited about the tech. They're moving into pilot. And they already know what a full-scale commercial system is going to cost. So what happens with us is we get to the answer no much faster. We don't enter into that bench scale test plan, bench scale test step, if a customer is not willing to, share with us what they're willing to invest in solving their problem. And so, we're working with customers that are serious, and we have we expect a very high turnover rate or conversion rate from pilot to commercial scale. And that's how we get to market now.
Okay, thanks. Craig, do you want to take it next?
Sure. Yeah, we actually announced our first commercial product at WEFTEC last year. We were planning to go into full production in Q2 of this year, taking some early pre-orders. Unfortunately, that's delayed now. One of our critical pieces of equipment got tied up in the global pandemic, unfortunately. So now it looks more like late Q3, early Q4 when we move into full production. We are doing test elements now, smaller quantities, 40-40 elements, few 80-40 elements here and there, and taking orders for those on a really limited basis because we are very supply limited at this point until we get our final piece of equipment to ramp up. And the first product we launched was this idea of putting more area into an element. We had a couple of customers specifically that were looking for an element that would keep up in the cold water months. RO systems almost always struggle with cold surface water to keep up in those winter months. So we launched a product called Arctic that put 600 square feet in a standard 80-40 membrane element. That same element could be used to expand your plant if you don't have cold water. And we're looking at other product launches probably early next year on a direct basis. We also have one partner that is in the process of finalizing their product. That's a public partner. Our core investor is Pentair, and they are using the technology to innovate one of their products, and will be launching soon their first product, but that is still confidential at this point of when they're going to launch and which one. So,
all right, thanks. Sivan?
Great. Yeah, we've got half a dozen, paying customers already, and We're continuing to approach the market, particularly industry verticals of power and industrial markets. And then we also have some customers on the municipal side, since wastewater reuse is becoming so much more popular, particularly in the United States. And then, of course, seawater desal and groundwater, particularly challenging and impaired water sources. And the way that we initially engage and work with customers is through an initial deployment, so a limited lease term of 6 months. And then should everything go well, we spell out specific KPIs and objectives for that 6-month initial engagement. And then should everything go well, then we continue forward to working with customers in 1- and 3-year contract terms.
Okay. And Devesh?
Awesome. Yes. So our commercial journey, when we started commercializing early this year. Before that, we were majorly working with alpha beta customers, around 30 plants, taking the data, refining our models. Because when you look at holistic plant optimization, things can get interesting and fun. And we were lucky, actually, in our journey to be recognized by Global Water Intelligence and Imagine H2O that allowed us to visibility. So our initial go-to-market strategy has been focusing on key markets, which have been India and US, where we have had deployments, and usually initially starting with private, either O&M or industrial end users. So right now we have around 9 deployments in different stages. And the customers we find get the highest value are the ones which have influent variations, higher OpEx, they're missing their effluent targets, and they have costlier downtimes. Some of the customers can be like Honda, Tata, on industrial side. So our go-to-market strategy now is to work with these, use our initial cases and case studies to validate ROI, and then work with channel partners in local markets to expand from there. How we would love to work with customers is through a low-risk model. Depending on the plan, we are able to provide a 6-month pilot or 12-month pilot or deployment where they can actually use the technology, see the ROI they get, and if they are not happy, which hasn't happened yet, they don't have to continue. So on the financial side and in terms of time commitment side, it's quite seamless, which we really try to aim for is the simplicity.
Okay, thanks. Sivan, there was a question that came in for you. And how do you maintain the same hydrodynamic conditions at the membrane coupon that exist at the membrane interface in the system?
Sure. So part of that goes to the core of our IP, but I'll answer that in any event. The RO Spotlight system is hooked up to a side stream or a sample stream of water that's coming from one of the RO pressure vessels. That side stream can either be coming from the very beginning of the lead element if you're more concerned about fouling, or at the end of your tail element if you're more concerned about mineral scaling. And then that water flows through that sample stream into the RO Spotlight hardware. Inside there, we've got a whole visualization module that includes a membrane coupon or sample that's taken directly from the plant itself. So the age and the history match exactly what's going on in the plant. And all of the geometry and all the hydrodynamics are exactly mimicked. And we have an automatic control valve that's constantly matching what's going on with the plant. So there's a number of ways that we do double checks. The customer can make sure that the conditions in the RO Spotlight are what's happening in the plant at the same time. That's you can look at it as an extension effectively at the very beginning of your lead element or at the very end of your tail element. You've just got this visual of the membrane and what's going on in the membrane in that location.
Okay. So for Melanie, had a question, and kind of generally speaking, what data do you have, and would you be able to share that data with this attendee on long-term performance, energy consumption, and how it compares to conventional tubular membranes and the same membranes without the SwirlTech invention? So basically, do you have a direct comparison between the two, and can you provide that data?
Yeah, that's an important part of what we're doing is comparing to conventional tubular membrane systems. One of the key differences in the SwirlTech's design is that we operate the tubular membranes in parallel as compared to in series configuration. And so that really helps with any kind of maintenance. You don't have to bring an entire train offline if there is a maintenance requirement on any single module or any single vertical stack in our case. And so from an energy perspective, because we're optimizing the fluid within the membrane surface, and we're able to pump a two-phase flow, meaning, optimizing using pressurized gas and bubble attachment upstream of the membrane, we're able to use smaller pumps to the tune of 30 to 40% smaller pump sizes to achieve the same permeation results as a conventional tubular membrane system in series. In addition to that, with respect to flux and sustained flux, we're seeing up to 100% increase in flux sustained over a period of time. Now, with respect to long durations, we only have up to, right now at this juncture, 4 to 6 months of data in because of where we're at in our evolution. So we're very excited for that longer term data to come as we grow and as we sell commercial products.
Did you ever run a system where you would run it first without your innovation and then with innovation and do side-by-side comparison or direct comparison?
We've done so at the bench scale, and we have a pilot plant that has 2 trains as well that we can do that in the field.
Okay. So, got a question that is for each one of you. So we'll start with Devesh this time. Could you go through what you find the biggest challenge, or where you find the biggest kind of resistance to change?
Good. It's a great question. I think what gets echoed a lot is that there is a bit of conservativeness when it comes to innovation in the industry, and it's in different shapes or forms. And I would say, the conservativeness is well justified, being the only utility we ingest. But when it comes to our technology, we see the status quo being Excel or analysis or consultants, and that same flow of using SCADA or DCS and then making decisions. So inherently what it comes down to is what's the risk our customer is taking compared to the reward we are providing. So at the early stage of the company, it's how much references you can build up to validate that reward to risk ratio. And that's just a matter of time. And, I want to add that I don't think it's specific to water industry. I think any industry where you have a tech, this challenge comes around. As we go forward, what we see would be a challenge we want to address, and this through our product is, winning the operators' confidence. I think operators, may be running plants for 5, 7, 10 years. So how are you working with them to make sure that what you're providing to them is something they can trust and implement? So those are some high-level challenges we face, and we try to look at more from their perspective and address our product, address our business model that can reduce the risk for them and relatively increase the reward.
Okay. And there was a follow-up question for you as well. Have you ever taken the surfboard to Tofino?
Looks like someone knows where we live. Before we were chatting before this webinar started, and I was mentioning this is a smaller surfboard. I think it's 6'2", and I would not float on this one. The surfboard I have taken to Tofino is much bigger. But yes, I'm actually thinking of going there this Sunday as well.
All right. So Craig, do you want to go back to the question about we had before?
Sure. I think,
resistance.
Yeah, most of us will probably echo the same theme, and lots of the attendees on the webinar have had the same experience that whether it's conservatism or just reluctance or risk avoidance or all of the above, I like to think of the why behind that sometimes. And it was interesting, one of the CEOs that ran GE Water for one of the 10 years when I was there came from aircraft engines, and he had this interesting observation that you'd think aircraft engines maybe is at or more complicated than the water treatment industry, but he found after a number of years that he felt it was actually much easier to make aircraft engines and make a profitable business because your inputs are air and fuel, and they rarely change. And in water and wastewater especially, your inputs are always changing, even at the same site. Once you come up with a solution, it's going to change the next day, the next month, as your water supplies change, as the regulations change on waste. And what that leads to is just literally thousands of methods to solve the same problem. And so then if you're an end user, whether you're a utility or an industrial customer, every week you're hearing about a new way to solve a problem that you have, and the complexity of why that problem is solved better with this solution versus that solution. And usually none of them are wrong. They're just different. They're different ways to solve the same problem. And so my experience has been that many end users just kind of throw up their hands and say, look, I have a problem. I can't decide what way to solve it, so I'm just not going to solve it. Or I'm going to take the lowest risk method to solve it, which is, what is somebody else doing? I'm not going to make the decision because it's so complex to pick what is the best solution between these 10 ways that people have presented to me. So I'm just going to call a colleague, I'm going to call an expert, I'm going to call a consultant, I'm going to depend on one of the consulting engineers, and they're going to suggest it. So I think that our industry in water and waste has such a level of complexity and variation that it will always be difficult for end users to choose, especially to choose new, because they already have 10 proven options to probably solve their problem.
How about you, Sivan?
So what Craig just said, I think is my answer. In addition to that, I come from a slightly different background. I'm a civil engineer by training, and I came up through working as a construction manager in heavy civil and also large commercial construction projects. So I quite literally come from a boots on the ground perspective of working with operators and superintendents, in the field, and so understand them very well. So I always come at it from a perspective when looking at resistance to change is really just connecting with the customer, and not just connecting with the customer in terms of making a sale or talking to them, but in terms of how you actually develop your product and your technology. Like Craig said, there's so many different technologies that are out there, and some of them are kind of alienating to customers, especially with a lot of the kind of AI and machine learning, which we're also doing. And even something so simple as, for example, showing pressure readings as a gauge through your software, which customers are used to, seeing in that way. So they don't have to get used to something brand new just because they're using a new technology. So I think that that's very important, is to, really take your customers into account when you're developing that new technology, so it's not a shock to the system in terms of how they interface with it. So that's kind of my 2 cents there.
Okay. And Melanie, do you have any other thoughts?
I just echo what everybody's already said. And one of the things, I'll just take this from a highlight from a startup perspective, to Craig's point about choosing something that somebody else has done before. As a startup, you're battling the chicken and egg issue every single day in every single aspect of your business. Can't get case studies, don't have any case studies. Customers need other customers' references, and so it's a real game of resilience and creativity to try and break that chicken and egg cycle to start getting that traction in the water industry, to be able to provide those case studies and to be able to have those conversations that work well, and totally echo Sivan's comment about operability and talking to the actual customer who's going to have to play with your system, and making sure that their ease of use is maximized.
All right. And then if a different question for you too, Melanie. Has there been a customer inquiry that surprised you? Has been a use case you hadn't thought of?
Yes. And this is yes, we had this customer inquiry come from 3 different angles at SwirlTex. And it has nothing to do with membranes, but what can you do with heat exchangers? Fouling, centrifugal force, buoyancy manipulation, tubular geometry, hits all the boxes. So very, very interested and ongoing research happening in that domain to be discussed at a later date.
All right, thanks. All right, we have 15 minutes left of this, so move on to some different types of questions here. Go through all of you again. We can start with Sivan this time. If you could go back 2 years, what would you have done differently?
Oh boy. That's an excellent question. One of the things, and I think that's just the nature of being part of a startup company or any company when you're developing a new product to come to market, is really making sure you hone in on your product market fit. I think that scares people a lot of the time in terms of feeling like they're potentially closing a particular door by focusing in very specifically on a narrow part of the market, be that geography or industry segments or applications. And I found that when we started actually doing that and just picking our 2 lowest hanging fruit, where do our customers derive the most value from, and where can we deliver the most value, we actually started making a lot more traction a lot faster. And so I would have told my 2-year ago self not to worry about closing doors, because those doors can always open back up later down the line.
How about you, Devesh?
Yes, I think that's a great question as well. And, I second Sivan on what she said. I think, I mean, before that, and I would do a lot of things differently. I think there have been more surprises than expectations in this journey of running a company. But I think finding that product market fit encompasses so many aspects of a business. If I would go back, I would definitely try to focus as much more as I could. Maybe just set up shop and live next to my customer for 6 months and really kind of hone in much faster than later on. I think even in terms of, and that focus, I think resonates after product market fit, also a team. I've been really happily surprised is how much a small, dedicated and focused team can achieve. But having that focus and surrounding that with the right feature set, right roadmap, right customers, right investors is a really interesting way to accelerate your business much faster than you can imagine. And something that resonates with that also I find is I read this somewhere. I believe it says entrepreneurship is a systematic way of retiring hypotheses, and if that is a path you take and you really focus as much as you can, I think it allows you to retire the right hypothesis and validate the right ones much faster than you would otherwise.
Okay. How about you, Craig?
Yeah, my 2 colleagues took the good answers, so I'm going to say the same one, but I'll go to a level deeper. The product market fit, I think, is critical. For us specifically, doing printed spacers, membranes are used everywhere. They're used in your home for home RO systems. They're used to make high fructose corn syrup. They're used to desalt seawater. So where are you going to tackle? Which customer base you're going to go after first, I think, is critical. But the other lesson that we have learned, again, and I'm pushing with my team lately that I wish I would have pushed sooner, is this notion of more people in your company spending time with the customers, even finance people. For sure, your salespeople, your market developers have to spend time with your customer, but send your engineers out, especially your engineers, maybe that aren't as comfortable spending time with customers, and see how they really use the products today that you're going to maybe replace or innovate, or maybe how they use your product. Early on in our journey, we were working with a lot of really big potential partners that would somehow kind of isolate us from those customers. And we've had to be really intentional with those relationships to get beyond the partner and actually get that direct customer feedback and spend time there. Not just a phone call, but send your people out and have them just sit there and watch them run a piece of equipment for 3 days, and they'll learn a lot from it. So I would have put my people out in the field more sooner. Now it's pretty tough because lots of people won't go in the field or even take visitors into their facilities. So I'm hoping the world gets more back to normal soon. But that would be what I would do more of 2 years ago if I do it again.
Good answer. How about you, Melanie?
Yeah, ditto all around. Product market fit for sure. If I could talk to myself 2 years ago, I would say find that sales process that gets you to the answer no faster that we're implementing now. We wasted a lot of time on people that were very enthusiastic but wouldn't spend money because, you know, it's fun to talk about your technology and people like it and you're going to get excited about it. But when they don't want to even pay for a small test or, you know, entertain the idea of doing business, you need to get to that answer very fast. So that's what I would tell myself.
Okay. And then I have another one of these general questions. So I'm going to ask, how is your product going to change the world? No, I won't do that. How will it change what the market segments you're targeting? How will it change what you're targeting? What will it make a difference in? Or what will that market look like 5 years from now? Devesh, you want to start?
Sure. Yeah, you know, I think what's been echoed and said before in this call, I think there is a clear gap in when an asset or a product is on the space and running. You know, it's like you build something in a different environment, but it's used in a completely different environment. So that really affects the innovation, I believe, in this industry or adoption cycle. And from our product's perspective, you know, having this operator coach that understands that asset equally as much as the people who built it could support the operators to run it properly much faster. And we believe that would increase the adoption cycle for newer technologies at a rate that the industry may have not seen before. And over time, what we believe is, you know, for plants that have been running based on limited data, not able to make the right decision at the right time, they have faced downtimes and higher operation cost. And once you change that, once you give people the data at the right time and they can actually change a little knob or a little pressure chemical at the right time, then you significantly reduce the life cycle cost of these assets. And that would eventually, you know, allow lower risk operations, especially for a lot of industries that are not necessarily water experts. They're making cars, they're making cement, they're making you know, beer. They're really good at doing that. And if they can have a low risk operations for the effluent treatment plant or their upstream plant, we believe will change how treatment is done and also the innovation cycle, because the gap of the skill set that operators have, they not necessarily are trained as engineers, could be merged by a coach that would allow better pilots, faster pilots for even near assets, and in general allow the industry to innovate and grow much faster.
That's a really good answer. Like that. Sivan, what do you think?
I'm going to quote one of our customers that, you know, recently said that he thinks that using the RO Spotlight technology as a part of a integrated plant design is going to be the way of the future. So no longer just looking at permeate flux and pressure differential as a way of monitoring plant and membrane performance, but actually having a direct visual also identification of what type of membrane fouling and scaling is building up on the membrane surface, and then bringing all that information and turning it into actionable information to operators so that they're empowered to make decisions, you know, at the operator and the plant level, and not always having to go and outsource, like Craig was mentioning before, having to outsource those decisions, you know, to engineering firms or otherwise, since they have, you know, the tools and the know-how how to operate their, you know, their particular plant. So I think it's really an operator empowerment tool so that plants can be operated more, you know, more efficiently. So we're really excited about it because I think, as you mentioned at the beginning of this repartee, Anders, in terms of how, you know, how RO is operated, it's basically, you know, been maximized to its utmost potential from the 1950s until today, and new technologies, particularly new digital technologies, as well as different membrane materials and design and processes need to be implemented in order to really push it to its maximum potential. And we are seeing membrane-based water treatment really increasing in terms of its adoption worldwide. So the technologies that all of us here on this call today are bringing to market really need to be adopted in the uptick in order to increase supply to meet that demand.
Okay. How about you, Craig?
Yeah, I'm excited about our technology and our ability to accelerate point of use treatment. If we look around the world at how water is used, where it's sent, and this notion that the rest of the world, as it grows in affluence and GDP, would follow kind of the U.S. Western Europe model of sending all the water to your home at the same quality, I just think isn't going to work in the rest of the world. And we need to get better at decentralizing treatment. Humans don't drink 200 gallons a day of water or 100 gallons a day, but depending on where you are in the world, those are kind of the ranges of per capita use. And so if we could get more affordable and more accessible point of use treatment in the developed parts of the world where we're worried about PFAS and other things, it protects citizens and others, and in some of the more developing parts of the world, then you can get decentralized water treatment at a train station and allow for better quality water to be decentralized more easily. We're only one small part of that. There's a lot of other great work that's being done, but membranes likely will be part of that, whether it's UF or NF or RO, and having them run longer and waste less water will just help move it quicker.
Okay, thanks, Greg. Melanie, what do you think?
Yeah, rising to the 30,000-foot view here, we want to see industrial users decrease their water footprint to close to zero. So we want to be able to help enable customers that create the most difficult wastewater streams, be able to reuse those wastewater streams within their processes. Oil and gas reuse, any kind of industrial application that creates a tricky wastewater stream that has high solids and oils that normally wouldn't be able to clean it up to the point of use like a membrane could, is our focus. So getting that water footprint to zero.
All right, excellent answer. I think we're about the end here. I want to thank each and every one of you for being on the call here. I really appreciate you taking your Friday afternoon and spending it with us. Also, thank our audience for doing the same thing. I hope everyone here enjoyed the conversation as much as I did. As I said earlier on, if you have a question you didn't get answered, send an email to John or me, and we'll make sure that it gets to the right person. And we will do another event like this in a couple of weeks. And whomever was invited to this will also be invited to that one. And feel free to share that with the people in your network. So thanks again to everyone, and have a great weekend. And it's time for a beer over here. Thank you.
All right. Thanks, Andres.
Thank
Thank
you.
you, guys.